All right. Good evening, everyone. May I please have everybody's attention? It's time to start this month's meeting of the Madison Astronomical Society. It's great to see a lively, large crowd here tonight. It's a pleasure to meet all of you. I'm Lawrence Moore. I'm the president of the society, and we will first go through a few announcements and maybe share a few stories, and then get to our presentation, this month's featured presentation at 7:30. Coming up tomorrow, weather permitting, and last I looked, it might be kind of cold, it might be kind of windy, but the skies could be clear, maybe some pretty good transparency. We're going to try to have a monthly star party at Yana Research Station tomorrow night at 6:30 p.m. So if you've got telescopes and stuff, join us out there. What? Or even if you don't, come and see what's going on. It's open to all members of the Madison Astronomical Society. Also, if this presentation just isn't enough information for you, coming up at this very place here at UW Space Place this Tuesday, March 12th at 7 o'clock, they have a guest presentation by Professor Juliet Becker from the UW-Madison Astronomy Department titled, How Do You Form a Hot Jupiter? And the background story is that the first type of exoplanet ever discovered around a sun-like star was a hot Jupiter 51 Pegasi b, discovered in 1995. A hot Jupiter is a planet the size of Jupiter orbiting very close to the surface of its host star. Despite the first planet of this type being discovered almost 30 years ago, we still don't understand exactly how these hot Jupiters form and why their orbits look the way they do. So that's coming up right here at Space Place at 7 o'clock, and although we're having issues with pieces being broken, they do broadcast their presentations on their YouTube channel, so fingers crossed they get the setup working better before this Tuesday, but you can also check out their YouTube channel. Coming up on Tuesday, March 19th and Thursday, March 21st at either 6:30 or 7:30 p.m., the Madison Metropolitan School District Planetarium is presenting Living in Balance. Join us for a planetarium experience exploring the full dome video production Living in Balance, Ashkenazi Star Knowledge, that highlights Ashkenazi stories of constellations and moons in relation to contemporary insights about environmental changes. Teachings will be shared by native sky watchers Carl Garboy, William Wilson, and Dr. Annette S. Lee. And these shows, if you go to the Madison Metropolitan School District website, you can buy tickets in advance. And I think I did not write down the price of those tickets, but they're pretty good. They're pretty cheap, a little more expensive if you're not a Madison resident. Any questions on any announcements so far? All right, and then next month, here Friday at April 12th at 7 o'clock p.m., we will have the Madison Metropolitan School District Planetarium Director, and he's also a Madison College professor, Ben Sensen, will be here giving a presentation entitled 1919, The New Universe, Echoes and Beyond, the Modern Eddington Experiment. John, did you want to give a lowdown, or I could give a brief lowdown of that?
So yeah, Ben Sensen is the planetarium director at Memorial, and many of you have probably read or know about the Eddington experiment in 1919, measuring the deflection of sunlight near a total eclipse. And that was one of the first proofs of general relativity. Ben and a team of people are replicating that experiment with 2024 technology. Our detectors are a lot more sensitive. We have a much easier time measuring the position of stars, basically aligning images. And so they're going to do photography during the eclipse. I think the sun is in Pisces, not a lot of bright stars. And then they're going to do photography 6 months later without the sun in the star field, and then measure to see if they can detect that 7/10 of an arc second deflection of sunlight. So Ben will be here talking about that on April 12th. The eclipse, if you've been keeping track, is April 8th. He hopes to have some results from whatever they find with that replication. So that's going to be a good talk.
It sounds really great, John. Thanks for arranging that talk. I can't wait to hear it. And then that's on Friday, April 12th. And then just the Saturday before that, we will be having our next scheduled monthly star party. That new moon creeps around again on Saturday, April 6th. So I try to arrange these so that we get there about a half hour before sunset, so give people time to set up their equipment and stuff, and then the sunset will be about a half hour later. So that's Saturday, April 6th at 7 p.m. And speaking of Yana Research Station, it's awfully rainy out there. So I'm anticipating if we do the star party thing tomorrow, there could be some mud, there could be some very soft ground. So yeah, we may have to be very careful about where we move our vehicles and spinning up mud. And so I'm thinking if possible, try to stay on the south side of the arborvitae tree line there, the bush line there. Just to avoid unnecessary cars getting stuck or damage the lawn. And we do want to remind everyone there are pads where we're not used to having pads, and there are power outlets sticking out of the ground where we're not used to having those. So be careful when you're driving around or when you're backing your car, not to hit something that you weren't aware was there. Any questions? All right. So that is a little bit of a announcement about Yana Research Station. I can't think, does anybody else have any announcements or news that they would like to share? Anybody? Is there anybody here who's never visited us at Madison Astronomical Society before? Would you like to introduce yourselves? Yeah, we are, just to remind everyone, we are trying to broadcast the show tonight. So yeah, if you want to ask a question, please wave at someone that has a microphone, and so that way the people online can hear. And also, if you have phones on, please put them in silent mode. So, okay, nice to meet you. What's your name?
Tony Vertis. I'm actually a member of the club for the last couple of years, but I had not made it here before.
Well, it's great to see you, Tony.
And I dragged my niece along.
I'm an eclipse chaser.
Oh.
Hi, Aunt Rosie, watching at home on YouTube.
Well, have fun chasing the eclipse. Who else would like to introduce themselves? Anyone? All right.
Leoval Rivera, I'm coming first time. McFarland.
McFarland, nice to meet you.
Long time member.
Hey, and so you have been a long time member?
I have.
Well, it's great to meet you.
Yeah, pretty solid. So.
Thank you so much for sticking with us. It's great to meet you. Oh, right next to me. Oh, wait a minute.
I'm Eric Lean, west side of Madison, and hoping to be a member tonight.
Oh, great. So yeah, you're brand new. Do you have any astronomy gear of your own? Or?
I do.
Great. Great.
I got 9¼ Celestron Schmidt cascade.
Yeah, that's a very nice setup. So yeah, one of the advantages of joining Madison Astronomical Society is you can join us at our dark sky observing site, and either if you don't have a telescope of your own, there's the membership form coming right there. If you don't have a telescope of your own, you can, if you're a member of the society, you can come on out and learn about what people use and what might be the best choice for you if you're thinking of buying your own gear, and you can get lots of advice and lots of ideas. So. And we do have equipment that people can use. Yeah, we've got a nice selection of Dobsonian telescopes, and we're getting more. Yes, that reminds me, we did just accept a donation from a longtime member who's not as mobile as he used to be, and another chemist that has an insane periodic table collection in their home. It was just amazing to see. But he's donating, was a 130 millimeter refractor that's a doublet. Doublet refractor is very nice. It's an older one, but it's in very great shape. And he's also donating a 14-inch Dobsonian along with that. So yeah, we recently also got a 8-inch Dobsonian, and we have our 16-inch Dobsonian. And we've got our ear to the ground on another 12-inch Dobsonian that another member's willing to donate. So we'll have to look into that. So there'll be lots of good telescopes for people to use. All right, yes. What is your name and what is your mission?
Hi. My name is Zach. Hello, everyone. I'm going to be eclipse chasing, heading over to Cincinnati for totality, hopefully, and also looking to join in. I've been interested in astronomy for some time. I'm a scientist by training, education, and profession, but looking to do some astrophotography. Yeah, nice to meet you all.
Nice to meet you. What was your name again?
Zach.
Zach, nice to meet you, Zach. And in case you know, a bunch of our members, there comes another form. A bunch of our members have been collaborating with Milwaukee Astronomical Society, and they do a monthly on the internet astrophotography and electronically assisted observing forum that you might be interested in as well. So there are a lot of astrophotographers in the club. So it's great to see you, Zach. Oh, yes.
Hello, I'm J.R. Schmidt from just a few miles south in Fitchburg, another fellow chemist, a few of them in the group tonight. And yeah, I've been dabbling in astrophotography and EAA for a few years now. Watched a few meetings online, but the first one I made it to in person. So
it's great to meet you. Great to meet you. Is there anyone? Oh, yes, one more.
Hello, my name is Alex Samuel. I just joined the Madison Astronomical Society, and I just moved here from New Hampshire. So I'm looking forward to being part of this group. And if this is a long shot, but if anyone owns a Takahashi FC100, I'd love to pick your brain and talk to you about that telescope.
It's a very fine piece of glass. You must be really deep in. Do you have one?
No.
Oh, you're just considering it?
Just like to ask.
You're about to get deep into the hobby here. That's fine glass. Yeah, excellent choice. Well, it's nice to meet you. And how's the skies out here compared to? Have you been in the dark skies areas around here compared to New Hampshire? Or?
Not yet.
Not yet. All right.
I'm sure they're fine.
Well, it's great to meet you. All right. Last call. If anyone else has any announcements they'd like to share or any anecdotes about observing. Yes, Dan?
I just wanted to say, since we do have a lot of new faces here, not everyone does join the club, but you're always welcome to join our Facebook group too. A lot of good information. It's very active. A lot of people post pictures and their processes too, and their techniques. So definitely join up.
That's right, and our monthly meetings here at Space Place are also open to the public, so keep on coming, even if you're not a member. It's great to see you. All right, we just got a couple minutes to kill. Yeah, I can't think of any fascinating news that I've heard recently. That I heard something on Science Friday today, but I'm just not remembering it quickly enough. But anyways, I guess yeah. What does somebody have the time? 'Cause I'm not sure if that 7:29. Yeah, it's pretty close. Well, why don't we go ahead and introduce. John, would you like to introduce this month's presenters?
So I'm tempted to welcome everybody to the Madison Astrochemical Association. So in case you haven't been keeping up on current events, there is an eclipse next month, partial eclipse in Madison. You don't have to drive very far to see totality, so I would certainly encourage all of you to find a way to get yourself under that path. Meetings like this are always more fun for me when we have people from inside the club doing the presenting. And we have a number of people who have presented to us multiple times over the years, and I'm really happy to have two of them presenting tonight, Bob Hamers and Jeff Shokler. I'm not going to introduce them because most of you probably already know them somewhat, both longtime members, both great astrophotographers. And was 2017 your first eclipse, both of you? So these guys are back for their second total solar eclipse and already making plans for 2044, just like me. So who's going to go first? Jeff Shokler. Give him a warm welcome, and then in a little bit, we'll also hear from Bob Hamers. And if you do have questions tonight, I'm going to go ahead and hold on to the microphone. If you have a question, raise your hand, and let me get to you with the microphone. Thank you. Thanks, Jeff.
Great, you bet. Sound check. Does this sound okay, everybody? Good level? Good level over here? All right. Thanks, everyone. And for those folks who are new members or considering being new members, you might check your wallet. Jurgen was so fast. I don't know if he picked your pocket. That was incredible. I'm really impressed how quick you moved, Jurgen. Yeah, I know. He is the treasurer, so he's not just coming up and working you for some money there. So welcome, everyone. We're very excited, Bob and I are excited to talk to you a little bit about how to prepare for the upcoming total solar eclipse. We use this word gobsmacked very intentionally because it really describes the experience of observing totality and kind of being there in that moment. 2017 was my first total solar eclipse. And frankly, your brain just shuts down when the event starts. It's a remarkable experience. It's very otherworldly. And what we want to do is try and help everybody think about how to prepare for success. Whatever success means for you in terms of your goals or how you want to experience the upcoming total solar eclipse. So you can see this sequence that I took. It's every 10 minutes, preceding totality, and then the moment of totality. I thought, hey, it'd be fun to put the word eclipse over that. So photography is one thing one can do if you want to for a total solar eclipse. We're going to talk about that, but also a lot of other things today in terms of helping you kind of crystallize your goals and plan for being successful, whatever those goals might be. First and foremost, I know you've all heard it, but I'm going to repeat it again. Safety first with an eclipse is just absolutely critical. No matter what your goals are, the safety of yourself and the others around you are really paramount in a solar eclipse. The others around you bit is something that I learned at the 2017 event. There were a whole bunch of folks there, many of whom had no experience with astronomy. And me and a couple other folks, including one other member from MAS, Ed Proctor, knew about the risks and dangers of observing a total solar eclipse. We kind of served as guides for everyone to ensure that everyone was observing and experiencing the event safely. You may be playing that same role wherever you end up for the event, so kind of keep that in mind. The other thing about the total solar eclipse is that, especially if you haven't experienced one before, when things start getting close, when totality is coming and when totality finally hits, your brain does kind of shut down. So it's really easy to make a mistake. And that mistake could affect your eyesight, right? Or the eyesight of someone else near you. So calling out when it's safe to take off filters or take off your solar glasses, at those moments, if you're aware of what the timing sequences are of a total solar eclipse, it's really important to pay attention to that kind of stuff so you can protect yourself and protect others while you're experiencing this really, really strange event and awe-inspiring event. So one of the big questions you want to think about in preparing for the eclipse is, what do you want to get out of this experience? Your goals are going to determine how you're going to prepare for it, and preparing for the eclipse is actually super important. Even if you just want to experience it, you're not going to take any pictures, you're just going to experience it. You want to be prepared for it. And we'll talk a little bit about some of the things you can do to prepare if you are going to take photos, but also if you're just going to experience some of the other phenomena as well as totality at the event. Do you want to experience it with your eyeballs? Do you want to capture some images? Are you interested in experiencing or imaging the other phenomena that are associated with total solar eclipses? Or do you just want to focus really on maximizing the imaging that you're going to be doing? And that's something I might try and do this time, because I have experienced one before, and this one's going to be longer than the last one. Last one was a little over 2 minutes. If you're on the center line at this one, it's going to be a little over 4 minutes. That's still not very long. This gives you a sense of why planning is so important. 4 minutes is fast. You don't have a lot of time to experience or capture the data that you might want to capture. Oops, going backwards. So there are lots of different ways that one can experience a total solar eclipse. visually, initially, with your eyeballs protected, right? Those solar glasses, great things. It's a great way to just sit there and stare at all the partial phases. And also to see the sunspots. We're in a very active solar cycle, so the odds of having sunspots are super high. And they'll probably be nice and big, which will be great. Sensory, so with your other senses. For those of you who haven't experienced a total solar eclipse, the temperature drops, the wind comes up, animals and insects and birds change their behavior. Sounds, different sounds happen. Automatic lights come on. It's just fascinating to see the things that are going on during a total solar eclipse. It also helps reinforce the idea of why ancient peoples really thought the world was going to end when a solar eclipse happens, because so much changes in the environment, and you have this black hole surrounded by a ring of fire in the sky. Another way to experience the solar eclipse in the entry and exit phases, partial phases, is with a pinhole projector or a colander, a simple spaghetti colander that you can hold and see the partial phases on the ground or on the surface of a table. Binoculars, if you have solar filters for your binoculars, which you can buy, you can also make them. Great way to experience the partial phases, also to see the sunspots really well. And during totality, when it's okay to actually have an unfiltered view of the sun, you can see prominences very effectively with binoculars. So don't forget binoculars as a potential component of your experience of observing a total solar eclipse. Telescopes can be helpful, but only if they're kind of wide field. If you're imaging, obviously you might use a telescope, again, one with wide field if you're trying to get the corona, or maybe you're going for the prominences that might be visible during the eclipse, again with proper filtering during the pre and post phases. And finally, cameras, and I have the parens plural. When I did my first total solar eclipse in 2017, I had 3 cameras going, one on a telescope, one on a tripod, and then my iPhone set up on a tripod about 50 feet away to capture us experiencing the total solar eclipse. I'm so glad I did that. It was so cool. And I'm going to show you that video in a little while. So, speaking of experiencing things, the visual and the sensory. Before the 2017 eclipse, a lot of experienced total eclipse observers told me, Jeff, I know you're an astrophotographer. I know you want to take pictures. Don't do it. And I'm like, why? Like, first, it's short. Second, your brain will shut down. Third, it's something that is a lifetime experience. It's just something that is truly an amazing, remarkable otherworldly experience. Just experience it. Don't have technology between you and the event. And I heard that, and I'm like, oh, I really want to take pictures of it. But I also want to fully experience it. I'm an astrophotographer, so I managed to balance. I think I experienced it for 60% of my attention, and 40% I was monkeying with gear. For me, that was successful. I feel really happy about how that first experience went. But believe me, right up until the moment really where I was setting up all that gear that I brought with me, I was really thinking about not setting it up because of that advice that was given to me. You should think about that too, particularly if it's your first total eclipse experience. The things that you're going to experience there are going to be like wind changes, temperature changes, colors. This was totally unexpected for me. So we had some clouds. I was in southern Illinois at the airport north of Carbondale, Illinois. And we had some clouds in the area on the horizon. I'm really glad we did. Because what you get is a 360-degree sunset during totality. The colors were mind-blowingly beautiful. The clouds themselves didn't look like clouds. They looked like they were made out of mercury in the sky because the light was so strange. They were all silvered
and somewhat metallic looking. Totally unexpected thing to experience and to see during that event. Shadow bands are things that you might see. They're a really unusual phenomenon. If you have a white surface that you set up, bring with you, or is near you, you might see these ripples of light occurring at the beginning and at the end of the total solar eclipse. Keep an eye out for those kinds of things. The sounds, again, the birds, frogs, cicadas start going. It's really, really interesting. And the other thing to pay attention to is your own reaction to what's going on. Pay attention to how you're feeling. Pay attention to what other people are doing and how they're acting. It's fascinating. But that being said, if you're going to take pictures, you want to know what you want to take pictures of. There are a lot of different things you can do, different phenomena you can image, different moments you can capture, different gear you can use and set up to capture events during a total solar eclipse. There are the partial phases, the other eclipse phenomena like those shadow bands, horizon effects like I was talking about, wide field. Believe it or not, wide field might be interesting to do during a total solar eclipse. I think John might be thinking about doing this, I'm not sure. Think about having an incredible landscape feature and the totally eclipsed sun hanging over that incredible landscape feature. Wide field is a cool thing to do during a total eclipse. Another thing is, when the sun is eclipsed, the stars come out, and you'll see the planets lined up along the ecliptic on either side of it. You can try and capture that, try and image it with wide field. Prominences, you might focus on the prominences that are visible during the event. The diamond ring effects, Bailey's beads, and I'll show you some of these things in just a moment. The question that you have to ask yourself is, what do you, if you're going to image, what do you want to image? What's going to be your goal or goals? You can't capture all those things. They happen very fast. It's a ton of gear and equipment, and frankly, different kinds of gear and equipment that you need to be managing. And you wouldn't be experiencing anything except managing your gear if you were to try and image all those things at once. So what you want to do is kind of focus and have an idea in your mind of the types of things you want to capture and prepare for that. An example of that pinhole or calendar effect, I shot this with my iPhone. You know, I had it on my hip, pulled it out. When I saw that, I was like, that's cool. Took this picture. One of my favorite pictures, actually, from the eclipse was this image of one of my gear cases with all the partial phase crescents filtered through the tree that we were under. Remember I mentioned that the shadow bands? So if you have a light colored surface, a large light surface near you, you might see these shadow bands. You can set out a white sheet on the ground to try and see those. We happen to be in an airport. That airport happened to have a large white air traffic control tower. And I set up, in part, you can see this is actually the direction that I set up my iPhone on a tripod to capture our own experience. But I wanted to see if I could get those shadow bands as well. I was not successful. Didn't see the shadow bands. Planning and testing for what you're going to do, super important. Today is March 8th. 1 month, okay? 1 month exactly from now, hopefully we all won't be sitting in traffic trying to get back from wherever we observed the event, because that did happen. It was very gridlocky after the last one. Keep that in mind. I, prior to the 2017 one, was trying to figure out what I wanted to try and capture if I was going to take pictures. So I set up my Canon 5D Mark II with a wide angle lens and solar filter on it. I started taking pictures of the sun with it. So you can see that's what the sun looks like with the 40 millimeter wide angle lens. Sun's really small. What would I see during totality? The eclipse sun, very tiny corona with not a ton of detail, stars and maybe those planets. So I had in my mind, maybe I'll capture the planets that come out during the total solar eclipse. I ended up not doing this, but I tried it, I tested it. I was trying to work to see if it was going to be possible and how I might be able to accomplish that if it was one of my goals. More testing. So I set up in my driveway with my 80mm refractor, solar filter on it, because I was thinking I wanted to capture a time lapse of the entire event. I did end up doing this. I have a tracking mount, so the sun's going to stay in the frame. Have the camera taking pictures at a regular interval. Make a time lapse. Remember to take off the solar filter during totality. Remember to put the solar filter back on after totality. That remembering part is hard to do because you're gobsmacked, right? Your brain's not working great. You're like, oh my gosh, look at that. Oh, solar filters, right? Thankfully, everybody's helping each other out. Ed Proctor was next to me. He's a member of MAS. He had his camera set up. 7 seconds after totality started, I was like, Ed, take your filter off. Because he was taking black frames through his camera because it had the solar filter still on instead of capturing totality. He took it off. He got some great pictures at totality. So, yep, more testing. Different camera lenses, different fields of view, right? So depending on what you want to capture, this field of view is not going to get you a lot of corona. But if you're taking short exposures, you're really trying to get the prominences, that's okay. This field of view, a lot of corona. If you're taking longer exposures, trying to go deep and get as much detail and structure and expanse of the corona, a wider field of view is what you want to do. The other thing that you're trying to plan for, what are your exposure settings, okay? You gotta know that in advance. Roughly what the exposure, the proper exposure is gonna be is critical to know in advance because you're not gonna have time to do a lot of adjustments to capture the data. 2017, we had, where I was, 2 minutes and 28 seconds of totality. That is not a lot of time to be fiddling with cameras, right? You gotta know what's gonna happen and be prepared for it. And you can't test enough. Something I learned in advance of the 2017 event was that the full moon is a great proxy for the totally eclipsed sun. Not only in size and scale, they're almost exactly the same, a little over 1/2 degree in angular width, but the exposure settings are almost identical. If you can get a well-exposed image with whatever you're using of the total, of the full moon, the exposures you need to get the total solar eclipse, the eclipse sun, is exactly the same. We have one full moon left, right, before the upcoming event. Use it to get your exposure settings ready, just about where you need it to be, so that you don't have to think too much when the actual event's taking place. The other thing to keep in mind is what's called bracketing. Overexpose a little bit and underexpose a little bit with each shot. Some cameras actually will do that automatically for you. They have a setting where you can overexpose by 1 or 2 stops for every shot that you take. Or more, in some cases, if you have a really smart camera. Oh, you. I don't want to hear it. You and your gear. But, well, yeah, exactly. But these are the kinds you want to think about. This is what planning for the event looks like. Because again, you're not going to have a lot of time. The events come in rapid succession. You do have to remember to take that solar filter off at the right time and put it back on at the right time. And you want to make sure you have good exposures. And, right, what's overexposing in air quotes going to get you? More corona, right? Longer exposures, more corona. The center might be a little blown out, but that's okay, because you can deal with that if you take multiple exposure lengths. You could stack them and adjust it and get maximum corona and nicely eclipsed sun in the middle. Things you want to think about, things you want to plan for. All that testing does pay off. There's what the full moon looked like, the same setup, same exposure settings. That's the exiting diamond ring from 2017 with some really cool high clouds. I did not know I had captured that until well after the event. I was looking through my data. I was like, holy crap, that's an artsy shot, you know? If you're going to take pictures, think about your mount. We had 8 people gathered around this rock near the airport where we were, and we thought, you know, it'd be fun to take a picture of all our tripods. So my actual telescope mount was not in that, but these are all the camera tripods that we had with us. You can see our setup with scopes and cameras around the rock. You can see homemade light barriers. I made cardboard cutouts, slipped it over the tube of my telescope to block the sun to make it easier to kind of see the camera LCDs and things like that. And you can see what was happening at game time, getting ready for totality. That day, we were lucky. This was not at solar maximum. We had some sunspots. Why are sunspots helpful? There were 2 groups that day. Focusing. Oh, they help focusing so much. So odds are very high we'll have sunspots because we're in a solar maximum. If you do, you're in good shape because you'll be able to get sharp focus. And then whatever you capture during totality, at least you'll know it'll be in focus. That is my best shot. Maximum, I worked the processing on this. I did multiple exposures to get it in 2 minutes and 28 seconds to get as much corona and as much structure as I could. The original image is more monochrome than this. I actually added the color to what I remembered seeing with my eyeballs. It was so unexpected that the actual total solar eclipse corona was this electric blue. I'd never seen anything like it. It was gorgeous, gorgeous. So I added that blue to make it like what I saw. But all that structure is real. And then there's that exiting diamond ring image. I'm going to show you this time lapse. Let's see if I can make this work. Remember I said I set up that camera, my 80mm refractor? This is what I got. Some clouds going by. And then that composite that you saw at the beginning of the presentation was every 10 minutes. I took one of the partials out on a 10-minute interval, and then totality. How are we doing on time? We should probably skip that piece and let Bob take over next. So I'm looking at our time. Yeah. Bob, you want to come in? Remember safety. Remember Bob. Here you go, sir.
Thank you
You bet.
very much. Okay. Thank you, Jeff. That was great. I'm going to switch over here to different presentation. And
later we can show that 4-minute video of all of us reacting to the solar eclipse. I want to make sure Bob has plenty of time and we have time to have questions.
I'm going to talk more about if you do decide to take photographs, what are some of the lessons learned? So I went down, like Jeff, I went down an image of 2017 eclipse from St. Louis. The conditions there were not as good as Jeff had. And then in October, I went down to Texas to see the Ring of Fire. So some of this will duplicate what Jeff had. but maybe a little different spin sometimes. So, Jeff mentioned a lot about preparation. I'm going to talk about some of the things that maybe I didn't prepare well enough for the first time. I kind of corrected some of those the second time. But one of them is thinking about your field of view and how do you predict what your field of view is. So there's a lot of freeware out there that you can use where you can put in a given camera, a given lens, and you can predict exactly what you will see at exactly the moment of eclipse. So one of those programs is Sky Safari. This is my favorite one. Sky Safari, you can put in a given camera that's of interest, and here I put in, well, this corresponds actually to Madison's location, and the maximum of what the eclipse will look like from Madison, where we will not have an absolute total eclipse, but you can see what the field of view would be in this particular case from a particular camera and lens. So that's very useful, again, in kind of estimating what you're going to see. Here's another example. The Sky Safari, at least the Pro version, costs a little bit of money. Another really popular one is Stellarium. Stellarium is free. Again, you can put in a telescope or a camera with a given focal length and your standard 35 millimeter camera sensor, and it will again kind of predict what you should. This is a little bit misleading. The little kind of center disk here is actually what the sun is, but this is the field of view, which can be rotated and other things. So very useful to estimate, like, what are you going to see at different locations, depending on where you're going for the eclipse, what should you expect to see, and what will you see with a given camera. All right, Jeff mentioned again that protecting yourself is the most important thing. Your gear can be replaced, but one of the challenges is you're dealing with gear. You've got to wear your eclipse glasses in order to see the sun, but if you wear the eclipse glasses, you can't see your gear, okay? So how do you manage to deal with your gear at the same time? And that's one of the things that I found was somewhat challenging. I will bring out one of the things that Jeff brought up about safety-wise is in 2017, there were a lot of clouds, and you could look directly at the sun through the clouds. And I just want to emphasize that that is very dangerous. Even though it doesn't hurt your eyes, the infrared light, which your eye doesn't respond to, your iris doesn't see it, can be very dangerous. So no matter what you do, make sure you're wearing your glasses. So then, in terms of protecting your gear, the common way of doing this is to use solar films. So solar films are available lots of different forms. You can buy, for modest sums of money, you can buy solar film that's mounted on a frame. The important thing is to clamp this onto your gear. Jeff mentioned the wind comes up. The last thing you want is for the wind to blow your solar filter off. It's happened to me. Right? It only takes a few seconds to damage, especially with a telescope, it only takes a few seconds to damage your camera. So you really want to make sure that's on, and you don't want to spend your eclipse time chasing your solar filter as it's rolling away, right? So you can buy, again, for modest sums of money if you're using a camera. I'm going to talk primarily about using a camera, like a 35 millimeter camera. In my opinion, if you're going to photograph the sun, you don't really need a telescope because you don't need high magnification, nor do you need a lot of light collection ability unless you're really trying to zoom in. So a 35 millimeter camera is kind of the sweet spot in my opinion. And so you can have solar films that are threaded, so you can use it like a filter on the front. And then you can simply buy solar film. So I prefer to buy the solar film. And so it comes in these 8x11 sheets. Comes from several different manufacturers. It's relatively inexpensive. Some of them have a shiny side and a dull side. Okay? You can look through this. I can barely see that light when I look directly through it. These are so-called ND5, meaning 10 to the minus 5 transmissions, so 0.001% of the light is transmitted through, and that is enough to protect both your eyes and your gear. It's the same transmission both for photography and usually and for protecting your eyes. These films are very thin. They're about 2,007 inch thick, so even if they're not perfectly flat, you'll see in the next slide, they don't have to be perfectly flat. They will have some waviness to them, and that is perfectly fine, perfectly normal. So you can buy filters like this. This is a commercial one from Bader. I had to slice off the edge of this, but you can see it's got some ripples on it, it's shiny, and it's got a safety straps. It's got some little rubber things that attach to the end of the telescope, and then also some safety straps. Okay, so that's one example. Oh, where did mine go? Oh yeah, these got a little bit out of order. Sorry. Here, we'll go back. No, we will try to go back. I like to make my own filters. So a nice way of making your own filters is you can simply buy from Amazon. You can buy these little step-down filter adapters for about $8. They provide a way of screwing onto the front of your camera, and they provide a nice little ledge that you can then cut a piece of solar film, put a few dabs of 5-minute epoxy or super glue on the end, and you can make a nice little filter that can then screw onto the front of your camera lens, and it's completely protected. There's no edges, there's nothing for wind to catch on or to rip it off, and you've made a solar filter for $10, right? So, now, there are solar filters available, or different films available from different manufacturers. I showed her the Bader one, which is silver on both sides. This is Thousand Oaks. It's silver on one side and dark on the other. They have different transmission characteristics. So the sun, we think of as being kind of yellow, but really the sun is white, okay? So the Bader film tends to give you kind of a neutral white. The Thousand Oaks, like I've typically used, is kind of an orange hue. Okay, it's very warm. This is an actual photograph from the October eclipse in Texas. Now, I simply point out that this is purely aesthetics, right? Effectively, for most of what you're interested in, monochrome is fine. There's really not a lot of information in the color of the sun because the color is almost uniformly white, except for something that I'll show you a little bit later on, which are the prominences. Okay. But it's just an aesthetic film. They cost about the same. You know, you can always recolor. You know, Jeff showed an example where he recolored the eclipse afterwards. You can very easily do that if you're using any of these filters as well. Camera phones with an iPhone. I've not had a lot of luck trying to use an iPhone to capture. I did at the October eclipse. I did put a solar film over my iPhone and tried to capture what the sun looked like, and I found I simply could not adjust the exposure correctly in order to not saturate the lens. The auto exposure on the iPhone was just swamping it out. This is probably more me, right, that I'm not an expert in the iPhone, and I'm much more comfortable with a 35 millimeter. Reading about this, I found there's some indications that iPhones might be able to survive imaging the sun even without any filter in front of it. Use at your own risk, okay? Well, you know, if you think about it, you know, it's not uncommon to take a photograph with an iPhone and to have the sun in the field of view, right? So, yeah, but, you know, this is like totally use at your own risk, okay? Actually, everything in solar is use at your own risk. It used to be that when people did visual of eclipses, they would use filters that would screw into the eyepiece, okay? I was absolutely flabbergasted. I did a search on Amazon, and you can still buy these, okay? For $1.72, you can buy a solar filter that will screw onto the eyepiece of whatever you happen to be using for your telescope, which means you've just sold your eyeballs to save $10, right? These are extremely dangerous. You should never use them. I'm totally surprised that they are actually for sale on Amazon as of last week, all right? So definitely do not do that. All right, so I mentioned that one of the challenges is you're wearing your solar glasses and you're trying to figure out how to focus, right? So how do you focus on the sun? Well, okay, one thing you can do, you need to be kind of roughly aligned. So one thing that's actually very helpful is to think about the fact that actually the shadow of your gear actually can tell you how you're pointed relative to the sun. So if I take a 35 millimeter camera and I point it at a bright light and I look at the shadow of that on the wall, it tells me, am I tilted too high or too low or too far to the left or too far to the right, okay? So you can get roughly aimed even without having to look at the sun at all, not by looking toward the sun, but by looking away from the sun and looking at the shadow. And this is just a shadow of my tripod with this same 35mm camera perched on top of it. If you want to get closer, the next best thing is to use a solar finder. So solar finder, right, very inexpensive, trivial little thing. It's nothing more than a hole about 3/16 of an inch in diameter that the sunlight will pass through and illuminate a piece of paper. All right. So I've 3D printed these. Anybody wants a Tinkercad file, I'm happy to send it to you. It's about 30 cents worth of plastic. Okay. Got a little thing that fits right onto the shoe of the 35mm camera. Slip it on, point it, and now this is in my backyard, right? So here's the sun shining through. I can see it from the front of the camera. I can see the sun. I can also see from the back of the sun. This will get me aligned certainly well enough that the sun will be in the field of view. Very easy to make. You can also buy these. They're overpriced in my opinion. $45, right? That's a lot of money for, you know, a little piece of plastic, right? So, yeah. So anyway, if anybody would like, I'm happy to send you my little design for this. Yes.
I just made one that worked great out of a pill bottle.
Yeah.
I saw it online.
Yeah. Anything. Just a hole.
Bottle,
yeah.
Paint it black on the top, and it worked like a charm.
Yeah. And just regular printer paper is translucent enough that you can see the sun no matter whether you're looking back at it or you're looking from behind. It's really good. One of the most difficult things I found is actually trying to focus in the presence of bright sunlight. And so many 35mm cameras or all iPhones have a pretty bright screen. One thing is you crank that screen brightness up so you can see it easily in the daylight. Your batteries are not going to last very long. So I went through 3 batteries in the course of the Ring of Fire eclipse in the fall, just trying to keep my camera. But I show these pictures, so here's the Ring of Fire, right? And this is just the reflection of my iPhone taking a picture of my camera, right? But you see how bright the reflections are, right? That actually makes it very difficult to like try to get your eyes around what it is you're actually seeing when you're looking at that screen. So you want to think about what can you do to block the rest of the sunlight. So when I went down to the eclipse in Texas, I built a little thing out of this like aluminized bubble wrap, okay, that you can buy at Menards for like a giant roll for, you know, $10 or something like that. What I found was that worked, but it was also acting like a sail, right? The wind was blowing that and it was literally shaking my gear around. So I actually gave up on that. And instead what I used was a sweatshirt. I used a sweatshirt as a shroud. I put the head over my head the wrong way, flip it up, all right, and kind of create a little dark region. Some people like to use a box and put their, you know, somehow try to constrain it that way. But it's very tricky. And so practicing how you're going to do that, remembering that, of course, the sun's going to be almost straight up. So that's a really inconvenient place. You can't look through the viewfinder. There's no way, right? You're going to have to rely on some other kind of screen or some other way of being able to focus. Or maybe some cameras, you could have this hooked up to a computer and look on the screen. But no matter what, visibility is a real issue in bright sunlight. So you really need that. And also autofocus, of course, doesn't necessarily work very well on these very unusual objects, right? Maybe if you set it up quite right, it might. But in my experience, autofocus doesn't work right. So you have either, as Jeff mentioned, sunspots can be really good, or maybe you can focus on the solar limb. If you have a 35mm camera and you don't use it very much, this is a Canon, but it's got this little magnifying glass down here. You can magnify the image either 3 times or 10 times and get a blow-up of some little region on the screen so you can really focus in on those sunspots. If you just look at the sunspots here, you can see them, but you'd never be able to actually focus on them, right? They're not big enough to really be able to get a good focus. But if you blow it up 10 times, you can actually do a good job of focusing on it, and that turns out to work pretty well. Right? So thinking about how do you focus in the presence of bright sunlight and make that work is somewhat easier said than done. So with that, here's just some images I got from the annular eclipse that was again down in Texas. A nice little series. You can see the sunspots. You can also see I'm taking all of these without a tracking mount. Right? You don't really need a tracking mount. If you don't use a tracking mount, bear in mind the sun travels its diameter in about 10 minutes. Right? So you can gauge from that. You're going to have to constantly be readjusting your tripod, readjusting its position in order to see it if you're trying to take fairly high resolution images. I'm using a 600 millimeter lens here, so I'm really magnifying quite a bit. If you're 200 or 300, you're not going to have to do it that often, but it's still going to be like every 10 or 15 minutes, you're probably going to have to readjust the position of your camera in order to keep it in place. If you think about doing a kind of a time lapse, also remember that if you are not using an equatorial mount, not only does the position of the sun change, but its apparent rotation also changes, right? Those of you who are familiar with alt-azimuth mounts versus equatorial mounts know that one of the challenges of alt-azimuth mounts is the field of rotation as things move across the sky. So the same will be true if you have a standard tripod, right? The sun will apparently rotate, and you can see that here from the position of the, well, maybe you'll see it later in my time lapse. You'll be able to see that these are actually rotating. You can see these are about 6 o'clock, or I'm sorry, maybe about 7 o'clock, and here they're more like 8 o'clock, those two sunspots in terms of the angle between them. So that field rotation is also something you're going to deal with. So some of the fun things to look for. So Jeff showed the diamond ring effect. Another thing that many people look at is what's called Bailey's beads. So Bailey's beads is a phenomenon where when the moon is in just the right position with respect to the sun, so if there's just a tiny little sliver left, you can see the topography of the moon. The mountains of the moon begin to obscure or not obscure that very edge of the sun. So here's a set of images over a total period of 7 seconds, okay? Not very long, but here's right at the very edge, and if you blow these up, you see here we don't really see Bailey's beads, maybe a little bit right here. 3 seconds later, or 4 seconds later, you can begin to see it's breaking apart. Here, it's breaking apart quite a bit. And then the next frame, which is 3 seconds later, total darkness. Okay. Now, Bailey's beads, if you are right on the center, if you're right in the center of totality, the only way you see Bailey's beads is just as the moon is almost eclipsing the sun, and it is almost done eclipsing the sun, because the motion of the moon, or the apparent motion of the moon, is directly across the center of the sun. If you're off the center of totality, you actually have a better chance of seeing it, because the moon will be displaced with respect to the sun, so the edge of the moon, instead of the top of the moon and the bottom of the moon, if you will, if you imagine the sun and moon moving like this, instead of having it be along the direction of motion, if they are displaced with respect to one another, which is what happens if you're off the line of totality, then in fact you can see Bailey's beads for a much longer time. I saw a news article that said in some places you might be able to see them for as long as 10 minutes. So anyway, that's a phenomenon that many people kind of ooh and ah about, as so-called Bailey's beads. So getting exposure right is tricky. Jeff showed some ways of doing this. I'll simply mention that thinking about using the histogram function on your phone or your camera is really useful. I like to use a camera and to save things as the CR2 RAW files. That's also important. There's a lot of post-processing you can do on these images, and it's much easier if you have a camera that can save in multiple modes. Save it in the most raw possible file, which is for a Canon is called a CR2 or a RAW file. PixInsight and Adobe Photoshop can both read in those raw files. But one nice thing is that that file also records all the information in it. So I've gone back here and looked at my images from 2017 and was able to pull out what were the exact conditions I used for each one of those, and use that now to guide what's going to happen in the next one. So just as a rough guide, I'm using ISOs about 400 exposures of about a 60th of a second and an f7. And here's the histogram. Again, note that with this Thousand Oaks film, it's orange, so the red is much more intense than the green and the blue, and you really want to avoid saturating, right? You'd like to make sure you've got a nice exposure range, and it's actually a little bit tricky to gauge that just by looking at the colors. And if you overexpose, you'll lose the detail in the sunspots and you lose other things. So you're probably better off thinking about exposing low rather than exposing too high, except during totality when you're really looking for the corona. So again, thinking about learning how to use that histogram tool in order to get good images. You can see here, this is, whoops, that was actually an image from 2017. And again, you can see the high clouds from the kind of large amount of scattering that's present around here, which would not be present if it was a nice clear day. The moment totality hits, your brain just goes, right? So what do? You whip off the solar filter, okay? And you've got to think, well, what exposure am I going to use, all right? I had no idea, right? So I just figured, okay, I'm going to boost up the exposure really quickly to 1600, and I'm going to get a nicely overexposed photograph. It shows kind of like the diamond ring effect, not nearly as nice as Jeff has, but it's an overexposed shot. So then the next one, I managed to back it back down. I realized, oh, okay, I've got images, but I'm a little bit out of focus. Now, at the time, I did not notice this interesting stuff happening along the right-hand side. But I realized I needed to focus again, and then with better focus, again, you can get something that looks like this. Again, these red things are appearing, and then with a little adjustment, you can get something where it, is beginning to show that corona. Again, not nearly as nice as Jeff had. The conditions where I was in Missouri, there was still a lot of clouds around during totality, which really obscured a lot of the ability to see that. But the thing that impressed me most about the entire eclipse experience that I never dreamed was at the end when I got home and I started processing the images and looking at them in Photoshop, I saw this red stuff along the right-hand edge. And I thought to myself, oh great, I've got lens flares, okay? And then kind of came back and thinking, well, but it's red. Why is it red? Well, hydrogen alpha emission is 656 nanometers. That's deep red. And I'm thinking, could it be that I actually could see these prominences, like with a simple 35 millimeter camera? Like, that just floored me. And then I went on to a site called spaceweather.com. So spaceweather.com shows you a view of the sun and shows you exactly where all the prominences are. It's updated very frequently. So I went back to the historical record to see where were the prominences at the time I took this photograph. And sure enough, these are solar prominences that you can see. I probably could have seen them with my bare eyes if I had really paid enough attention to doing that. Or, yeah, bare eyes at this point. But like that just totally surprised me. I had never in a million years dreamed that you could actually see prominences directly during an eclipse like that. Now, one key is how do you know what exposure to use during totality, right? So Jeff had one suggestion, which was to measure what the intensity of the moon is, all right? So in preparation for this, I went back to those photographs I took from 2017, and I said, well, what were the conditions I used to get the image of the moon, the image of the sun with the solar film in place, and what were the best exposure conditions I used at totality? And they're shown here, but I was kind of surprised that really pretty much all I needed to do was to remove the filter. If I had just removed that solar filter, you would actually be pretty close to an ideal exposure, maybe off by a factor of 2, but with a little bracketing, that's actually not so bad, right? So that really surprised me a lot, and I would actually be very interested in going back and talking to Jeff and see if that kind of jives with what he found in images of the sun and the moon taken with his camera. course, these will depend on your focal length and your f number, but like this ratio between before totality and after totality should be completely independent of what camera you're using. So maybe you don't really need to do much other than whip off the filter and start taking photographs if that's what you're going to do. So if you want to take longer photos, guiding is important. Those of you who do deep space imaging, looking at DSOs, are very familiar with the idea of guiding on a star, right? Well, the sun is a star, but you can't guide on it. Right? It's too big. So if you are dead set on guiding and getting images where you're actually tracking the sun, say using an equatorial mount, you can get close to that simply setting up your equatorial mount so that it's guiding at the solar rate, which is different from the lunar rate, which is different from the normal rate. And there is a device that's sold by a company called Astronomical that is a combination little finder. So here's a little hole, and there's the image of the sun in the back, but also has a little sensor that you can use for auto guiding on your equatorial mount. I have one of these. It actually works pretty well, but they're expensive and not really useful if you're just going to image the eclipse once. They're several $100s, so it's really not worth it unless you're like really serious about doing solar imaging. The alternative, if you want to make some kind of a time lapse, is you want to somehow align the images. All right, and it turns out that the software that most people use to align deep space objects or to align images of the moon really don't work for an eclipse because the shape is changing as you're going through the eclipse. So that's a bit of a challenge. That and the fact that there will be some rotation as well. So even if you tried to align on somehow you could align on the sunspots, that would probably also be a challenge in terms of getting that to work. There is a lot of free software out there. So I actually have spent a lot of time in the last few months looking at other kinds of free software. If anybody's interested in coding a little bit, I've been coding a lot in Python, looking at other options for doing open source and free software for aligning images. So I wrote a little program in Python that actually does alignment of images. So again, just using an unguided mount on a tripod, and it's not perfect, but it actually is pretty good. You can see the sunspots rotating through as you go through. These images are kind of like Jeff's, maybe every 10 or 15 minutes apart or something like that. So it can be done, okay? But a lot of the commercial software, it's not specialized for eclipses. It's specialized for deep space objects usually, and the imaging conditions are totally different. Usually they align on stars, so it's very difficult to do with this kind of an image. So if anybody wants more information about that, I'm happy to supply my little Python code. Everything's open source and free, or I can help you to do it yourself, or I could potentially do it for you if you do get to the point of doing something like that. So best thing is have fun, right? So with that, I'll just wrap up, and I'm sure that Jeff and I would be happy to take any questions that people have.
So if you have any questions, just raise your hand and I'll come to you with the microphone.
Carol has her hand up here.
Bob, for you, do you think your losing focus had anything to do with the temperature change? Is that something to be aware of?
That's a good question. So I have a filter that screws onto the front, and I think I didn't have the focus lock on, and then when I unscrewed the filter a little bit, I think I just tugged on it. So, but that's a good question. I don't know the answer to that.
I can throw something in. I've photographed the night sky with these newfangled plastic lenses, and they will change their focal length enough, at least with stellar objects, to take it right out of focus.
What's a plastic lens?
I don't know how to describe it. I use legacy glass. My optics on my camera are good 10 to 15 or 20 years old. The new stuff are plastic bodied lenses, and the thermal difference between the glass in there and the actual body of the lens will change the actual focal length enough to take your image out of focus. as the temperature drops. It may not be enough during the eclipse, but who knows? My question was, I've been toying with the idea of taking a high resolution, higher magnification video of the corona close to the limb. And I know from taking already video images of prominences in the chromosphere on the limb that over like a 4-minute period of time, there's not much movement. So it may not even be worth the trouble. But I was wondering if anyone in here knew whether or not the corona viewed close up, because I've got images of my own with beautiful streamers coming out. I wanted to know if close to the sun, and if, especially if there's a magnetic storm of, like, you know, a sunspot group near the limb, whether or not there's going to be any actual motion that can be picked up in the corona on the limb.
That's a great question. I mean, I've done H-alpha imaging where you can see like streamers changing over a period of 1 or 2 minutes, but that's sort of unusual, right? Most of them are kind of steady, so it's probably a little bit, right?
You know what I'd say is that if that's a goal, that'd be really cool to find out.
Yeah, yeah, right, exactly.
To do that as an
Yeah.
experiment would be fascinating, because I don't know if it actually will change within that kind of a period at that rate, but it sure would be cool to find out. And a 4-minute, 18-second total eclipse is a good opportunity. I mean, the longest ones are, what, 7 minutes? So it's a good shot to see whether or not you can see variability in the corona at that scale over that kind of period of time.
We could maybe go back and see. I've never actually gone back to see whether that prominence actually changes significantly, right? So that data, they're not the world's best images, but might show something.
Jeff, I'll remind you to try to share Bob's mic when you're talking.
Oh, sorry.
Yeah.
Oh.
You can hand it over.
Yeah.
So I can add a little bit of insight to that. I do a lot of solar imaging. You've probably seen my work on your website. When I'm imaging like prominences like that, it's generally several hours before you can actually see one, you know, flip out or something like that. So in the 4 minutes, I really don't think you're going to see any. Well, but so the corona is a magnification of the prominence. So the corona won't change like the prominence will. It follows a similar shape, but in the 4-minute time frame, I just don't think you're going to see, because like I said, that would be awesome. That would be awesome if we did. I plan on having a hydrogen alpha scope set up as well, so I'm really hopeful.
So I have a technical question. I'm planning to take along my spotting scope, which I have a 1000 Oaks filter, full aperture filter on it. But yesterday, the focus knob fell off, and when I went to put it back on, I realized that the collet that it turns was jammed. I couldn't turn it with my fingers at all. I tried very carefully with a pair of Cobra pliers to turn it. It was jammed. I've done some preliminary searching for a place to get this repaired. I came up dry. Does anybody know of a place that does repairs to spotting scopes?
What brand?
It's no boy. It's called a Raven.
Eagle Optics.
Eagle Optics Raven, yeah.
I think so. Yeah.
Neil?
Yeah.
You might try BCD cameras here in town, because they do camera repairs and lens repairs. I bet you they could help you with that.
I did call them, and they said they don't do that. Thanks though.
Yeah.
John.
It is vortex. Look at it. They're local. They're out of what?
I thought Eagle Optics was local.
Yeah, they're out of. They went out of
Middleton.
business or whatever.
Eagle Optics is out of business.
Yeah.
Eagle Optics is now Vortex Optics, and they're, yeah.
If you contact them, tell them what you got.
Yeah.
They're real responsive. If you got a problem with any of their technical.
Middleton.
Yeah, they're somewhere just on the west side.
Vortex, VRTC, or TX?
X.
Vortex. Okay, thank you.
But don't hesitate to call them because they are extremely responsive. If you've got a problem with their equipment.
Great, thank you.
All right, I just wanted to share a resource that I found very valuable at the last Eclipse, and I think you guys might enjoy it too. Bob talked a little bit about some specific exposure values that he benefited from, and there's a fellow named Fred Espenak who some of you might know of, who has photographed dozens of eclipses around the world, and he made an exposure guide that you can find on the internet, and it's basically just a chart. I've went into Photoshop and I highlighted my own values here, say ISO 100 at f6, where I know my rig is going to be, and it gives you an expected exposure value for all of. If you Google Eclipse exposure value, this is going to be one of the first thing that comes up. And there's also another guy who basically made like a web app version where you can put in radio buttons. But it's also worth pointing out, an eclipse is both an extremely difficult but also an extremely easy thing to photograph at the same time, depending on what your goals are. If you just want to get that picture of totality of the sun black with the corona around it, there's a lot of exposure values that you can get of it with a telephoto lens, with very little effort and with very little drama while you're there watching it. If you want some of this other stuff, if you want Bailey's beads and that corona image, now you're talking about work. I had mentioned earlier that my camera, my high-tech new camera, will bracket 9 stops in 1 second. There are 14 stops of different things you can photograph on this eclipse, going from Bailey's beads at 1/8,000th of a second to Earthshine on the moon at 4 or 8 seconds. So if you have like a Nikon or a Canon camera, you can automate all of this, where the camera will do all of the work take the right exposures that you pre-program at every second of this without you having to make any intervention. While you're sitting in your lawn chair, that's the way to do it. If you don't have all of that and you just want to go simple, bracket as much as you can. Most cameras will do 2 or 4 EVs. And in the middle, something like my camera, since I can do 9 stops, I'm going to, during those first few seconds when the Bailey's beads are appearing at C2 and again at C3, I'm going to have them pre-programmed. I'm just going to press a button on my phone that's going to take a bunch of pictures. And then once totality starts, I can leisurely, in that 4 minutes, dial down so my 9 stops are on the longer end. And so that's kind of the in-between option.
Yeah, when we were talking about your incident with Ed where he didn't take the filter off and that type of thing, and also having to, experienced astronomers having to tell people when to put filters on, when to put filters off. There are apps out there right now you can put on your phone, your smartwatch, and I believe they're both for iPhone and for Android. Solar eclipse timers.
And it's audio, so it will verbally tell you.
So when your brain goes, and this will not, and you will hear it tell you filters on or filters off.
It also has the exact times if you want to set up to take pictures at all.
If you decide to use something like what Carol is recommending, these apps have practice modes, so you can practice now. You do not want to be learning how to use an app at first contact. And speaking of Neil's story about his focus knob, you do not want to be futzing around in your trunk looking for a pair of pliers while the totality clock is ticking. If your focus knob falls off, sit in your lawn chair and enjoy totality.
Yeah, enjoy totality.
I just wanted to mention to all of you, because I had a disturbing cloud issue in the Eclipse I went to see in Manitoba in 1979, where we had a significant amount of cloud cover. If that happens to you and it's possible, don't despair and just give up. Open your, or slow your shutter speed down so that you get more and more light in. And through the clouds, they're not going to be the greatest thing, but you will pick up, like I did. I was using a 6-inch f8 refractor at the time, and I picked up the prominences and a very, very small amount of the very close to the limb corona. But if you're not willing to at least give that a try, you just probably standing there cursing in the clouds. Give that a try. Be ready for it at least, and you'll get something.
Hi, Jeff. I wish I knew that you were in Carbondale in 2017. I went to Carbondale, but I was at the football stadium, and it was complete cloud at exactly the same time of totality.
Yeah.
And not only that, I completely forgot to take out my solar filter. And it took me a while actually to understand exactly what was happening.
Oh, yeah.
So I actually missed it. Later on, I saw the video. So for those, that was my first eclipse, so I almost missed it.
From the airport, we saw that cloud.
Yes,
exactly. On our southern horizon, we were like, oh crap. You know, we think that's a football stadium with 15,000 people in it. And the cloud was right on top of them. Yeah.
So the other thing that I want to ask you is, recently I have been putting my iPhone mounted into my 6-inch Dobsonian telescope, and I got a very good pictures actually. So that's the way how I wanted to do it right now. If any of you have experience, because it does takes you from the stress of focusing and things like that. And you just click one at a time as you want it. But while I was experimenting here, I just took out the cover, and the lens of the camera just melted. Just melted. That was the first time I figured out how dangerous this thing is, honestly to tell you. If that could have been an eye. So thankfully I changed my iPhone, but I just want to tell you, it is really dangerous when they say that. Thank you very much.
Yeah, thank you. I'm so sorry that you had the football stadium experience.
I have a totally non-technical question. So let's say your wife's friend moved away from Indianapolis and there goes Plan A. And you're kind of chasing rural Illinois, rural Indiana, kind of his tentative plan. You find a spot, well, those of us who can't go down to Texas, where do you go? You find a town. Where do you go?
Yeah, parks.
So
I'm going to go down to Dallas because I have family there, and they said you're coming to Dallas and I'm like, okay, I'm going to Dallas, but I'm not going to stay in my brother's backyard where he will have 30 seconds of totality because he's not on the center line. I'm going to go to Sulphur Springs, Texas, an hour and a half away, and I used the Maps app and I zoomed in and I found a park. And I Googled that park, and I've learned all about it. I know where I'm going to set up. So you can do some research, and the best thing you can do is find a park. It's not particularly safe to just be off on the side of the road. Really, really dangerous idea to do. And actually, in some states during the last event, the state patrol said nope, and they kicked people off who were trying to do that.
Places like athletic fields, cemeteries.
Yeah. High school
That's
fields.
what I was going to say. As we were driving through Tennessee on our way to Chattanooga area, there were signs all along the highways, and that the highway patrol was putting up, and it says no stopping for eclipse. So don't try to just do it along the highway or something.
It's just really dangerous.
I got from schools would be, it's a school day. Won't they all be taken up by the students? Wouldn't they drag all the students out and take a look?
The one school, the one school got like 1,000 of the glasses donated.
Oh, that's
and they
cool.
said, no, we don't want our kids looking at the sun. Think of the lawsuit.
Oh, that's true.
I have to say that's up to the
Yeah.
individual.
Also check out local grocery store parking lots and things like that, because Piggly Wiggly in Chattanooga had they were actually selling T-shirts that say, I saw the eclipse at Piggly Wiggly.
saw the eclipse particularly. Oh, one tip.
I was in Nebraska for 2017, and maybe not so much in some of the more populated areas, but there were farmers who had fields
in
the middle of the path of totality.
Yep.
They maybe wanted $50 to park your RV there, but they were all over the place. There was no problem trying to get in the path of totality.
One thing I remembered from when Bob brought it up in his talk was the whole issue of solar filters blowing off or losing focus because you accidentally touched your focus ring on your lens. Tape. Seriously, tape those down, an extra layer of security for your solar filters, masking tape. Same thing, put tape across your focus ring. Once you get focus, gently put it down so that you're not going to wiggle or jiggle the things accidentally. Painter's tape, masking tape, that kind of thing, which should work.
In 2017, we went to Lincoln, which is just on the edge of totality, and then drove south to find a place to go. We were clouded in, so we didn't really see much. But we did find a farmer who made a whole lot of money that day. The place was crowded, and they were serving food.
Nice.
So you can sometimes get a good lunch out of it also.
Yep. One other thing before we wrap up that I neglected to say, which is make a checklist as part of your planning. Bob mentioned power. If you're going to take any pictures, batteries, backup batteries, backup batteries, 100-foot extension cords, outdoor extension cords. If you've got a tracking mount that requires power, make sure you've got your power and a backup for that. You don't want to be caught without the gear that you need. Don't forget your tripod. I did that once. So I drove out to YRS, had all my gear, not my tripod. Couldn't set up. It was very embarrassing.
And take some weights with you too to weight down your tripod in case it's windy.
Exactly. And also food and water. Because remember, the gridlock after this thing is going to probably be like it was in 2017. You may be sitting in your car for 3-4 hours trying to get back to wherever you need to go.
My wife bought some portable, basically porta potties, anticipating that all the infrastructure is going to be saturated in Texas.
I love it.
I bought a great ebook that was recommended by one of the resources that was put on the Facebook page, and it's Alan Dyer's Eclipse book, and it was a PDF, and it is a wealth of really, really good, well put together information. I highly recommend
that
ebook.
A week or two ago, the club had one of the emails talked about a good site for doing Eclipse, and there were 3 or 4 really good apps in there. The one where it tells you when to put your glasses on and take them off. There were, one of the things, there's 3 videos. This one guy did 3 videos. One is different kinds of a setup, just a binoculars, camera, tracking mount. And then another one was about the photography. One of the things he said, if you're going to use a telescope and you've got a guide scope on it, make sure you put a filter on the guide scope or take it off, because you'll fry the guide scope.
For sure.
But find that email, and there are several links in it, and it's really, really helpful.
John, since I'm a member of the club too, I got that email, and the video was very good. I will go ahead and post it on our Facebook group for the benefit of the people who aren't on our email list.
I can do it too.
Okay.
I sent it out originally.
Oh, you're the, okay.
Anybody else?
I was just going to say, I had some real high-tech people with me, and I'm pretty low-tech. But what I did is I just took one of the glasses, ripped it in half, and put it inside my phone case.
Yep, that would
and
work.
I got some pretty decent pictures
Solar
of
filming.
the last eclipse.
If your phone is all you have, you can do some pretty good stuff with your phone.
Thank you. I was just wondering if anyone is going to try and capture the comet that's also in the sky that same day, the 12P. I know it's going to be tricky.
Yeah, the comet is 25 degrees away from the sun.
Yeah.
So it's worth trying on a wide field shot.
Yeah.
But I'm not optimistic because the comet is pretty faint.
Mm-hmm. Oh, I think you just
To answer that question.
We can. Yeah, that's all right. Yeah.
To answer that question about the comet, it is brightening. They're estimating it could be 6 magnitude by the day of the eclipse. I suggest you just keep an eye on spaceweather.com. The guy who runs that is providing data on that constantly, because it's a geyser producing comet, and it could flare up at any time. So just watch that website, and you'll find out what likelihood there is.
If you think about Jeff's comment with the eclipsed sun being approximately equal in brightness to the full moon, think about photographing the full moon with a 6 magnitude comet 25 degrees away. That's not a very promising shot. Jeff, are you going to try the video?
Oh, gotta get the HDMI back in. Yeah, the wrong one. I think. Pull this out.
I guess while we're setting up, I'd just like to remind everyone, this will be the last highlight of the meeting tonight, this video. And remind everyone we'll be back here on April 12th, Friday, April 12th, and we hope to see you. And one last advertisement for safety first.
Yeah.
You get like I did. I got multiple pairs of sun safety glasses sent to me. I was very careful to read the instructions and to treat them with utmost care. I'll tell you, the day I was at the park in the Path of Totality, I saw people, they were stuffing those glasses in their pockets. Ooh. And they're not the sort of thing, you don't want them to get scratched, you don't want them to get bent or wrinkled up. Otherwise you put them on and you risk permanently damaging your eyesight. So please, I urge everyone, treat those pieces of equipment with the utmost care and be sure to read the instructions more than once. So have a good month, and we'll enjoy this video. Thank you.
Hopefully the sound.
And I'd like to thank both Jeff and Bob for their presentations.
Hold on. Yep. Well, you can do it. Nothing. Where's the sound? Oh, that's true. We'll do that. Where's the speaker? Oh. Can y'all hear that? Okay. You'll hear us start yelling and hooting and hollering soon enough. So watch, look at the horizon. See the horizon? Keep the lights on. Look at the horizon. So the moon's coming from the west. The shadow is coming from the west. Look at the brightness of the tower. That wasn't me doing the woo. I think I was saying holy crap a lot. See the lights came on in the tower? Automatic light down below.
Don't forget to breathe when this is happening.
So I would just shouted planets on either side. So people were repeating planets. 360 sunset. Birds, cicadas, cold, cool breeze. Look how dark it got. It got really dark. And this whole time over here, there's this black hole in the sky surrounded by this actinic blue flame. It was just remarkable. See how it's getting brighter in the west? No, it was folks who were more tuned in. We didn't have any automated apps to the timing. That was trying to just inform everybody. And you'd hear it get repeated. There were like 700 people at this airport. A lot of people flew in. Really dark. So you'll hear us start telling people to get ready to put their glasses back on and their filters back on. So as the totality was nearing the end, we were starting to say, get ready, because you don't have to have filters or glasses during totality. See how bright it's getting over in the west? That wasn't me either, because I think I was saying holy shit. I'm pretty sure. Do you hear the cicadas? Frogs too, which was really cool. Now we're talking about filters. Get ready for your filters. Watch how quickly it brightens up. Cicadas stopped. And then you'll hear the human behavior in just a second. And the clouds were just this weird metallic silver color. It was so strange. So that was it.
Great video. Good luck, everyone. Have a great time, and we'll head out of here by 9 o'clock, and we'll see you next month. Have fun.